This one in particular, it's at a beautiful venue. Pretty much everybody's staying in the hotel here. And so that means, after the sessions, people are going out and getting a beer and continuing the conversation. And it's just a great way to experience the conference.
Good afternoon, and thank you for coming. We are going to speak about hiding your implementation details. A few words about myself. I'm a lecturer at the Academic College of Tel-Aviv-Yaffo and Tel-Aviv University, a member of the Israeli ISO C++ national body. I'm also the co-organizer of the Core CPP conference. This is a t-shirt from the previous year conference and a meetup group of the same name. I'm also a trainer and advisor, mainly C++, but not only. So hiding your implementation details, I think that we understand that, it sounds important. This is why you are watching, this is why you are here, but why? Why is it important? Well, I think that we know in a way that it relates to the principles of encapsulation that bring value by hiding things that the user of your code should not be exposed to. And this gives you, for example, the ability to protect object integrity. You know that nothing will happen for your object which is not exposed to the public. It is easier to use. You are not exposing things that should not be used, and then there would not be any accidents of, oh, you called a function that I didn't want you to call, or you accessed a member that you shouldn't access. It improves maintainability because internal changes do not affect any external code, and it's easier to debug because you can easily add breakpoints and see what actually happens, and things happen inside your functions and not by changing data members, for example. So encapsulation is a principle that is behind or is leading to hiding your implementation details. It also goes with decoupling, because once you hide things and you expose only the actual things that the other side needs, then you decouple the caller from the usage, from the implementation. All the unnecessary details are not exposed and thus cannot be used, and thus are decoupled from the actual use. So it reduces dependencies. I'm not dependent on something that I do not expose. And again, it facilitates changes because it is easier to change things that are not known to the other side, enhances reusability. Once I do not bring with myself too much noise, only the necessary things, that then the thing can be easily used and can be re-implemented for other usages without any additional noise that I want to avoid. And it improves the stability because I need to test only the actual things that I expose. I don't need to test things that are hidden because they're hidden. So I isolate the actual things that I want you to use from things that should be hidden. So why is it not so simple? I mean, we understand the importance. And we usually, by the way, try to do that. I mean, we put things in the private. Is it enough? Do we always do that? It's not only me saying that it is important, and it is not so easy. The person who first came with hiding your implementation details is important is David Parnas. He is known about introducing the idea of modules, modularity in software development, and the idea of hiding your implementation details. This is from one of his talks, and he says that it is harder than it looks. Now, there are some reasons here. I will take my reasons in the following slides, but in a way it was hard back in the 70s. It is hard also today. If you want to follow talks by David Parnas, you can find there are some links. This is from 2018, quite a good one. So the ideas that came in the 70s are still relevant. and we still need to make sure that we follow them. And it is still a bit complicated. So what makes it not so simple? So first, because in some cases we are a bit lazy. Lazy not in a bad manner. Lazy in we have other important things to do. I mean, okay, let's skip that because we need to do, we have priorities. And in some cases we are not sure that something is really important. So due to time pressure, we just skip the fancy design. No need for a fancy design for this one, just use a struct, put all in the public. And we don't think that it is important because in some cases we think, okay, we can change it later if there would be a real reason. Would it be easy to change it later? Not so. I'll give you an example of something that I would say that was a bit lazy, and then I will discuss later why I think it was a mistake to begin with. Stud pair. Stud pair exposes first and second. First and second are data members. They are exposed in the public. There aren't any getters. So you can actually access first and second. Someone was a bit lazy there. I mean, does it really matter? I mean, yeah, it's just first and second, we just, access. I would argue that, yeah, it should have been in the private with a proper getter, and I will explain why, but let's remember that one. Someone was a bit lazy there because maybe someone thought it is not so important. In some cases, we do not realize that we actually expose private details, like, for example, this function. What is exposed? Something is being exposed outside. I mean, it's a function. I do not expose the member. My members are in the private, but the fact that this class most probably holds a map of strings to ints is exposed by this API. I mean, if later on, why the class most probably need to hold this map or hold someone who can provide this map, because the map is returned as a reference. So most probably I don't want to return a value that I create inside the function, a local. And in a way I'm saying this is a map. You will get a map. And if later on I want to return some kind of another associative container, it would be quite hard to change it. If I want to change the key, it would be quite hard to, I mean, maybe a key that behaves like a string, but not a string. It would be quite hard to change it. So I expose something on the API, and the question is, can we not expose that? And in many cases, we just, write the function, think that that's fine, and then it hits us when there is a need for a change. And the change is either impossible or very costly. Because of technical constraints in some cases. In some cases, we do not hide implementation details because, well, we couldn't do that. I mean, maybe we can, but it was a bit complicated. Like in this example, I want a factory method called create to create a foo object. And the best thing would be, if I do not want you to create foo on your own, you should go through the factory. I would have preferred to put the constructor in the private, but I can't. Why can't I? Because the factory calls makeUnique, and makeUnique needs to call the constructor. And you cannot friend makeUnique. It is problematic. So if you try to say, let's put foo constructor in the private, you will not be able to do that easily or in a proper manner. And then in some cases, you just leave it in the public section, and then the result is that even though you want the usage of this class to go through the factory in order to create a foo instance, you want the user to go through the factory, users could still use the constructor. That's implementation detail that I have a constructor. I would want to hide that. In some cases, the reason that we do not hide implementation details is because there are trade-offs. And we do want to expose some information. Like, for example, we want to allow the user to know that we would provide back a vector. Why? because then you can use it as a vector. If I would just say, okay, we'll get, let's say, an iterable, something that you can iterate over, okay, then is it a random access iterable? And I want you to be able to access by index. So I say, okay, we'll get a vector. Is it okay? I'm not sure. Maybe we can do it better. Maybe I can still say, yeah, I do want to expose the fact that I'm providing back some kind of a random access container or random access range, but without saying the exact instantiation, the exact type that I would provide, because then I still hold my freedom to change the implementation later. So in some cases, we think that we do need to provide some information, mainly for performance reasons. And maybe there is another way to do that. So our goal in this talk is to investigate code examples to see how we expose implementation detail, understand why it's not the best design per case, and propose a better design. Let's start. And we'll start with stud pair. I just argued that having first and second on the public section in pair is not the best idea, and I want to convince you. And if I convince you, then maybe I will convince you to stop, maybe you stopped already, not to use public members, data members, even when it seems like, oh, it is just a stud pair. So I would say it's a language accident. Why? Because it might be that I want to write a generic function that accommodates stud pair, but should accommodate any other type that behaves like a pair, duck typing. So if you are a pair, if you are stud pair, or you behave like a pair, this function should accommodate you. So I want to write a function that can take stud pair or something like stud pair. And then this is the function. Let's say it gets a pair, and inside I print first and second. Now, it doesn't have to be stud pair. It can be anything that you implement. And then you come up with, okay, I have a pair. My pair is a lazy pair. And the lazy pair gets only the first, and the second is evaluated lazily. Now, it might be that I do not call second, and then the second shouldn't be evaluated. But the way that pair works, both first and second are data members. So in a way, I should expose, the constructor takes the number 7 in square pair, and then I should calculate the second, because I need to expose first and second. And maybe in another function, you do not need second. So the way pair is implemented, in a way, affects other implementations that want to behave like pair, even though they are not stud pair. By the way, there is a solution how to avoid calculating second. Do you have an idea how we can still do that? But it would be cumbersome. I would want to avoid that and do it much more easily. And yeah, if it would be a getter, a get function, it then would just decide when to implement, when to evaluate second. So the way to, if you still want to behave like a pair and have a second which is lazy, the way to do that is with a proxy class. You could have a member which is a proxy class with a casting operator, and only when the casting operator is called, then you evaluate the actual value. But it would be a bit complicated. I mean, you can do that, but that shouldn't be your approach to begin with. So I argue here that stud pair, in a way, dictates for other types that we may want to implement the way to use the members, which is not what we want in general. So structs in general, I mean public data members. I would say that if you have a struct and you say, hey, it's only price and quantity, and I even use here strong types to be safe. That's good. No, I would say no, they should be in the private. And then you say, I just provide them to a function, which should, I mean, if it would be a class, there would be a setter and a getter, and it's just redundant code. No, it is not, because at some point, you want to support a generic order. And then comes another order. Again, let's assume duck typing. And this new order says, I mean, if I would use it like that, I can then use another type which says, you know what? The actual price is not a single number. It depends on the time. Let's assume that there is a function or a vector or something inside, internal, that calculates what is the price that I want to expose, what is the current price that I want to bid. So if it would be, again, 2 members, like we started, we have a problem with that. I mean, if you send me now something that the price is calculated, it would not fit, unless you go with the proxy class and casting operator, and that's complicated. You don't want this boilerplate. So I would say, yeah, it should go with private members, and then you save the liberty to implement, in this case, a duck typing. I mean, I still want order to behave like that, but then I have a time order, and both should go to a function that accommodates an order. And being an order is being able to provide the price. It shouldn't be a public data member. But what if it is a const member? I mean, let's take another example. Let's say we have a const long ID for a person. And that's in the public because, you know, once the person is born, the ID is initialized, and then there isn't any need to change it, and why shouldn't it be in the public? Why? Because all the reasons are still relevant. I mean, maybe we want to change it from long to another type. And then someone can say, oh, but then your getter would change. Yeah, but then maybe it would be easier for me to still support a getter as a get long and another getter. Maybe, you know, I can amend the functionality. It is much harder to amend usage when data member type, which is public, is changed. So let's assume that you say, oh, it's not a long because it should be the SSN number. But if the person doesn't have an SSN number, a social security number, then it should be his or her passport number. Okay, so now we have some functionality. And we still put it in the public because we say, okay, now we have the proper ID type, and it is still const. Is it still const? No, because passport numbers change. So requirements keep coming on, and the requirement now says, you know, passport numbers change. When you issue a new passport, you get a new number. So the ID is not const anymore. And eventually you say, you know what, it was a mistake to begin with to assume that ID should be in the public. Data members should be in the private to begin with, because then you have all the encapsulation values and decoupling from, do you have an ID? Yeah, I can provide the ID. Do you store the ID? Maybe not. Maybe I go to somewhere and grab my ID. I don't know. Takeaway. Keep data members and static members in the private always to begin with. I mean, someone can ask, but then maybe I just want to provide to a function a struct, and the struct should hold the arguments. I just, you know, put all the arguments in struct so it would be managed together. Why should this struct become a class with getters and, you know, all the boilerplate of? Because again, maybe later on this struct, duck typing or non-duck typing, would change its functionality, and instead of a price, you would want it to be a lazy evaluation of the price. Once you say, okay, these are the data members on the struct, it would be quite complicated to change it later. So my advice here is start with private members, private data members. Let's continue to API, including internal API, because when I talk about API, even if it is an API between two classes in my own code base, I still want to decouple different classes. It would serve my testing, it would serve the ability to change things. So when we talk about API, we know from IOM's lore, I think that I assume that you heard about that, the developers come to depend on all observable traits of a certain interface, even if it is a non-documented behavior. And with sufficient number of users of an API, it doesn't matter whether you promise something on the contract, all observable behaviors will be dependent by somebody. So what we want to achieve is not to allow you anything that is not in the contract. I mean, once you allow something, even if it is not documented, somebody will use it, and then somebody will abuse it. Let's make sure that we don't do that. Studies show that applications tend to use small part of an API. Unused API is much more bug prone. Why? Because it is unused. It is not tested. I mean, for sure it is not tested in production because it is unused. Maybe it is tested, but I guess that the test is not so good if it is not being used. We ever talk about that? Jody spoke about, right, the bug that lost $460 million because of unused code. Don't have unused code or unused API. When there are too many options, too many overloads, the wrong option would be selected at some point. I mean, there was an overload. Oh, I used that one. No, you should use this one. Why should you have so many overloads? I mean, too many options are not something good. You should have the proper amount of options. Less options mean also less required tests. So be lean and mean. I mean, in real life, try to be kind and nice. But when you come to your day job, being a programmer, be lean and mean. When somebody asks for, can you please provide another API, another additional overload? The answer should be no. Simply no. Why? Because you can do that with the other API that already exists. Yeah, I understand. You have to prepare some argument. You have to create this object, but you have all the relevant data. Why should I do that for you? You can do that on your side. But then the other side says, yeah, but then I do that here and there. Okay, maybe you can create a facade. But once I will provide that, the other team will use it as well, and the other team should, I mean, they will get confused. You will get confused at a certain point. And then I will have also to support and maintain and test all the APIs that I provide. So be lean and mean. Keep your API short and concise. Limit your API to what should actually be used. And different usages may get different view of the same data, and we'll discuss that. I mean, the API is or should not be the same for every user. It depends on the user. I gave this talk at CPP North in Toronto a few months ago, great conference. And then I related that to a few previous talks on the same conference. So I'm keeping the same slides, even though it is from CPP North. There was a very good talk by David Zaleski on cognitive load of programmers. And the bigger the API, the higher the cognitive load. So keeping concise API is good. Less code is less code to decommission. Peter Mulden talked about that. And we keep the O in solid when the API is small and concise. And we make the code easier to test. All these are talks from CPP North. When I gave this talk, I related to these. And as I said, it is context specific. So to discuss context specific, let's understand that interface that we provide should be as narrow as possible. I mean, if I know that that you should use a certain function and you should not use any other function, even though if I have the other functions for another use, maybe I shouldn't provide the other functions to you because you shouldn't use them. How can I do that? Can I do that? Let's take a koan from Tony Van Aert. Tony Van Aert had a known koan. I will take you through this one. A koan is a short story with a moral. Okay, so we'll have a short story. I take the version from his Twitter. The same appeared in one of his talks. So the master and his dog. The master travels, just takes his dog along, and he sees a student just in his backyard working on some code. Master, I'm honored by your visit, says the student. I was walking out my dog. Your function, says the master. Why does it take big common struct instead of just x and y? The master is asking. Big common struct, the student is answering, is where we keep x and y, master. That's a valid answer, I would say. Bark, the dog then barks. He's hungry, the master says. Shall I prepare him food? The student asks. No, just open the fridge. Let him take what he wants. Did you get it? Should we open the fridge for the dog? Should we provide the same API for every usage? So, Act 2, I added this part. Master, though I trust your dog completely, I still got a concern, the student says, quite politely. What's your concern? The fridge engine is in the private. I mean, the dog would not hurt the fridge. Are you're worried about the fridge? The fridge would work. No, I'm worried about the food. But when you open the fridge, you're not so worried. Yeah, but the dog and the student are not the same. I don't know. They should not use the same API. So it is context specific. Something may be required to be public for one usage and yet have no reason to be public for other usages. Because if they don't need it, don't give it. If they get it, they will use it. And if they use it, they will find a way to abuse it. Trust no one. Trust no one was also the keynote of today on security. It's on security. It's safety, security. Trust no one. If you provide something, it will be used. And then it will be misused. So you have to provide it in a way that only someone who should actually use it would get it. Having things in the private is not enough because, yeah, I still have the function in the public and this function shouldn't be in the public. That's a problem. So how can we do that? How can we expose only what is needed? There are language tools. And the language tools that we may want to use are value semantics, send values, instead of something that can change. Send a copy of, okay, these are the values that you have to work with. Then the function would compute something and return a value. Okay. Like, for example, don't send big common struct. Send x and y, might be. But then maybe you have to send x and y and z and many other variables, many other arguments, and this is too much, so maybe we have to wrap them. But wrapping what I have to provide to you doesn't really mean that I have to provide the original thing that had all this information. We can go with interfaces. I can provide an interface, and then you will use the interface. It goes well with dependency injection. It will be easier to test also. We can use the pimple idiom. I will not discuss too much the pimple idiom, but the idea is that you would not even see the header of what is provided for the full implementation. I would use something, but I will expose something which is smaller. I can use a wrapper class to wrap the actual thing, but to expose only the things that you should use. And I may use C++ concepts. We will discuss that. So let's take an example. This will be an exercise. Are you ready for an exercise? Can you open your compilers? I want to initialize a map. Then I want to pass it to a function in a way that the function can modify the values, but cannot alter the map itself. The function should not erase values, keys, entries in the map, and the function should not add entries to the map. The function may change things in the map, okay? So I may go to a certain entry, and of course, if I change an entry, it means I change the value, not the key. If I change the key, I altered the map. So I have the map, either a map, unordered map, and I want to provide it to the function, and the function should not alter the map. Now, if I would provide the map, let's think. I can use a concept in a moment, but I can use the documentation. I can send the map, and on the function signature or somewhere, I would say, do not alter the map. What do you say? Would it help? Yeah, it might work for a few days. I don't know, I'm not sure. At a certain point, somebody in the function, can I send the map as a const? Maybe if I had const on the map, would it help? No, because once it is const, the entire thing is const, you cannot even change the values. So, okay, I want to suggest a concept approach. A short manner, let's discuss concepts. The full presentation has many slides here to discuss concepts. In CP North, I had 90 minutes, but here we have 60. So there will be only 2 slides about concepts. A concept is a constraint on a template argument. evaluated to a Boolean value at compile time. And it can help in overload resolution or in making the code not to compile. So here we have an example of a concept, meowable. A meowable is a thing that can meow. A meowable requires a function on t, a const function, because I get a const t that can do meow, that is called meow, and doesn't get any arguments. So a cat is a meowable because cat does have the meow function. So if I have a do meow function that says I'm going to take a const meowable outer, which is a template function. Once you have an outer argument, C+20, it's a template function. But the template function, in a way, narrows the actual usage. I mean, I'm saying to you, I want to get here something which is the meowable. Now, if you send something which is not, it will not compile. Okay, that's an approach. So let's go back to our map. And what I suggest is, let's have a concept. For now, without implementing that, just think about the concept. Let's call it const dict mutable vals. So the dictionary, the dict is const, but the values are mutable. This is the name. And let's assume that we can implement something that would require the proper functions. And then inside, I just change the values. What do you say? Did I do a step in the right direction? No, that's wrong. Something is really wrong there. The function itself is wrong. I mean, when you write into d at 1, it might be that a new entry is created. The rectangle brackets, the at operator for map is not const. And it can change the map, not only the values. If the key 1 exists, so I changed the value that is associated with key 1. But if key 1 doesn't exist, then I just created that. So no, that was not what I wanted. So let's assume that the concept does not present the rectangle operator. Let's assume that the concept presents, as the concept, const dict mutable vals, the things that I provide, or the things that I say that you should have, are the find method, and let's assume end, okay? So you have a find, you have end. With these, you can do something, but I assume that you cannot add. I mean, maybe you could. Maybe I return end and find. End would be returned as a const iterator. So this seems a bit better, but the problem with concepts is a concept requires things, but then something would come in. And then you can use anything that is on the actual type that came in. And the concept is still fine. I mean, if I provide a map, inside I can modify the map. It's not compilation error. The only thing is that whatever you provide must adhere to the concept requirements. But then it's not that it is checked that you are not using anything that is not on the concept. Can I, in a way, improve that? Can I, in a way, say, you know what, that's true, but still, a concept is kind of a documentation saying this is what you should expect, and if you do something else, I will catch you. How can I do that? With a simple test. You can have a simple test in your testing that actually calls this function and provides a class that adheres to the concept, but do not provide any additional function. Only the functions that you said that the concept or this argument would provide. I mean, if I have a class that adheres to the concept and provides only the functions that I say that you will get, your code would not compile for this test if you do something else with this argument. So maybe a concept with a proper test, I can make sure that you are using my map as I wanted you to use. It's not as strong as not allowing it, but it might be fine. I mean, the language itself is using that in many cases since C+20 on APIs. If you want to think how this concept would look like, the concept would say, we have an iterator and a key type and a map type for this argument that you are providing for this concept, and it should have a find function, and the find function should have a not equal with an end function. So all these things that are in the concept are being checked as, does this type that we provide at compile time adheres to these requirements? And again, I should still check that the function doesn't use anything else. Let's talk about the wrapper approach. The wrapper approach would be quite feasible and easy thing here. I can do the following. I can say, okay, you get another thing. Let's call it a const dict mutable values. And I want you to use, what is your actually type that you're using? I mean, it might be a map, it might be an unordered map, so whatever you send me. So the type is templated over the actual type that is in the wrapper. But I don't really care in the function. And the only thing that I provide in the wrapper is the assign function. So you can only assign, which is you can only change a value in the map. The wrapper would look like that. I would have a wrapper, const dict mutable values. Let's assume that I have a concept for dictionary that says, in order to be a dictionary, you should behave like a map or unordered map. You should be associative with keys and values. And the wrapper would just take the reference. I mean, I hold the reference to your actual dictionary, to your actual map or unordered map, but I do not expose all the functions. I delegate to the proper behavior that I want to expose using the assign function. Now, it's an overkill. Would we do that? Not always. Should we do that? Yes. How much time does it take? Yeah, it takes some time, but then I have something that is more maintainable, safer. You would not do something that I didn't want you to do. Less bugs. And I hide private implementation details. Yes, this is what we want, in a way, either with a concept, which is a bit less strong, or with this wrapper. Let's talk about other cases, hiding smart pointers and hierarchies. I have another talk in which I implement a math expression. So let's assume that we have a math expression, and this math expression is being built with a new sum, which holds a new exponent, which holds numbers, and eventually the entire tree is being held with this expression pointer e. I don't like this code so much because there is 1 delete and 5 news, and I don't like the usage of raw memory allocations. I would prefer using smart pointers. So let's say, yeah, you convinced us, let's implement that as using smart pointers. So, it is unsymmetric calls to new and delete, like, as I said, 5 calls to new, 1 to delete, but there isn't any leak because it's a tree. And the call to delete cascades the allocations of all the actual sub expressions. So let's refactor that to use unique PTRs. What do you say about this? Okay, now the user is using smart pointers because I changed the class. The class is now using smart pointers. The class is now saying, okay, in order to build a math expression, you should provide unique PTR of the operands. So your sum, please provide 2 unique PTRs. What do you say? Well, I will say that it is quite noisy. There are too many implementation details. I mean, the main implementation detail that bothers me here is that you expect a unique PTR. And it might be that later on you will expect a shared PTR. Well, that will work because the unique PTR can convert itself to a shared PTR. So yeah, that would work. But let's assume that you want another representation. So I would go maybe with hiding your unique PTR. What do you say about something like that? I want to create a sum of exp, of number. I mean, do you see here anything that's saying, and there would be unique PTRs inside? No, but there will be unique PTRs. They will be born inside the constructor. I mean, the fact that you are using unique PTRs is not necessarily something that your user should know of, because it adds noise, and it is implementation detail. And once the user knows something, then it would be quite hard to change it later. The code looks much nicer, and things are now being, in a way, hidden. It's, in a way, going to value semantics in this example. So it is much better, I would say, compared to, okay, please provide me unique PTRs. No, I don't want to get from you unique PTRs. I will create the unique PTRs. And it can be as efficient as the one that actually creates the unique PTR. How do you do that? So in the constructor, you get something, in this case, templated, and you create the unique PTRs inside your class. And then you have the liberty to change this implementation later. Yeah, I do need dynamic polymorphism in this example, let's assume. Why should the user know about that? I want to, I don't want the user to be interfered, to have to deal with this hierarchy or the notion that there is an hierarchy here. So this would be quite simpler, which goes with, I think, the idea of inheritance, base class of evil. So use inheritance, but it is not that you have to expose the fact that you are using hierarchies all across your code, which goes well with design patterns like state pattern, strategy pattern, which says, okay, I have a state, and the state has hierarchy, but that's only the state. It's not that I'm part of an inheritance hierarchy. I want to, in a way, hide that. So hiding implementation details for this case is that the user doesn't have to know that we use unique PTR. We may want to change it later, and it is noisy. Hiding inheritance hierarchies goes well with state pattern employees and employee. Let's assume that we have two kinds of employees, internal employees and subcontractors. So we may think that, okay, the best thing is to inherit internal employee and subcontractor for employee because they behave differently in some cases, okay? They have different functionality. And then in all functions, we get the pointer to employee, and actually we get either the internal employee or the subcontractor. That's wrong. Don't do that. Employee is an employee. The universal message. Go with the universal message. Why? Because once employee is an employee, your code would become much simpler. You hide the implementation detail that, yeah, we have different kinds of employees. You are right, but that's an implementation detail. I hide that. You know that in some cases, that's quite common. At a certain point, a subcontractor may become internal employee. Now, if we go with the inheritance thing, an employee is the base class, and we have the inherited types, the derived classes. So we say to this employee, you know what? Yeah, you're becoming an internal employee, but there is a small thing that we need to do. Don't worry, usually it works. We first need to kill you, and then we'll revive you as an internal employee. Are you sure? Yeah, it is. Usually it works. Now, there are certain problems with that. First, it might be that in certain places in code, I still have pointers to the old object. Now, I would have to amend these pointers. It's a new object. Another problem, I have to copy all the fields that are managed by the base class. I mean, its name. And if I forget to copy one of the fields, then I have uninitials or default initialized value on the other side. One of the fields, by the way, is the email. And IT department says that since when you create the new one, the old one is still alive, I cannot give the same email. So we'll get a new email. Yeah, but what about, it will be quite the same, we'll just add the digit 2. And what about all my old emails? You will have access to it for the coming 30 days. You see that there are problems by saying, oh, we did the inheritance too soon. Employee should have been just an employee. So state pattern says, delay the actual inheritance to the small features, the small states that actually behave differently. Strategy pattern goes the same with things that are not the state, but the behavior. If I'm a pathfinder, why should you care if I'm BFS or DFS? I mean, you shouldn't care. And let's assume that I want to change my strategy while running. Why should you change the object that you hold? So again, value semantics in a way, and hiding your inheritance makes your code easier to maintain, and you hide implementation details. Factory method goes the same way as well. Why? Because you need to create something. I don't want the logic of what you want to create to be in your code. I want you to come and say, okay, I need a shape with these arguments, and oh, this looks like ellipse. I don't know, this looks like, and it might be that I would not create the same thing that you would have created, and still you get something that you can work with, and is the actual right thing to create. So I want to decouple the logic of what should be created, how should it be created, from I need this. Okay, I will create it. Don't worry. Don't tell me how. I know how. And then again, I hide implementation details, and I have the liberty to change them later, to say, you know what, I have a better implementation for this use case. And you don't have to change it in your code. It is changed in the factory. Let's talk about other issues. Conveying less information on return values. What do you say about this function? We are conveying too much information, right? I mean, why should you know that the foo function returns a vector? I mean, maybe later we would replace it with in-place vector or pseudo-array. I mean, there are other types that may fit, but once we say that, oh, we are going to get a vector of ints, it would be quite difficult to change things. It's not a pointer to a base class. It's not an interface. But eventually, it is a vector. This is what I return. What else can I say here? I mean, I should say something. I have a cheat. You could say that. What do you say about this? Yeah, I hide implementation details. Yeah, that cheat would not work. It wouldn't work because the other side, the caller, needs to know what are you returning. I need to work with that. Then it will, the other side, she will go into the function, see that this is a vector, and they will use a vector. I mean, auto is too generic. It's hiding too much. I still need to say something, because if I say nothing, you will go and fetch, what is the actual type? So I want to say something. What can I say? What about a concept? So let's say that I return a random access range of int. By the way, there isn't in the language a concept like that. It is created in the link below. There is a concept for a random access range. But it is a generic random access range, and I want to say that I am providing a random access range of ints. It is quite easy to create this concept. You are using the random access range concept and adding an additional requirement that the value type of the range is t. And the t is provided in the angle brackets. So this random access range of ints says, okay, this is what you should expect. Now, that's okay, but then the user, and we discussed that before, can still, on the caller side, can still use things that are on vector, because eventually the user can go inside and say, oh, this is a vector, I would use things as vector. How can we make sure that testing would be quite hard here? Because in order to test, I need to return something else. So I can, maybe, it would be quite hard, but maybe in my mock tests, I can test a user and mock this implementation and provide something which is not a vector and see if your usage, your actual usage, not a mock usage, your actual usage works well with a mock that actually returns something which is not a vector. And if it works, then I say, okay, you relied probably on getting a random access range and not on getting actually a vector. Okay, but I said something which is less than saying that I return a vector. And in a way, if I would change it later to something which is not a vector, you would complain, my code doesn't work, I would say, but you used something that was not on the signature. So I can use a concept. There are some caveats. It is in C++20. If you're not on 20, it's not so possible. It works only on functions implemented in the header, because it works, a concept eventually is like saying outer. And the compiler needs to deduce the actual type from the return type. So it works only if the implementation comes with the signature, which means, okay, the implementation is in the header. And compiler doesn't check if usage conforms to the concept, as we said before. Another option is to return an interface, and this example, it would be quite hard because vector is a vector. What is the interface that I can provide? Vector doesn't inherit from any interface. But then I can say, okay, I will create a wrapper, and then maybe I provide the wrapper, but that's quite a work. So you can decide which of those you want to do, but saying that you return something quite specific is a problem because you expose implementation details that will be used and then misused. Beware of leaky abstractions. In some cases, you want to hide something and you do not hide it so well. Do you have an example of something in the language that hides something but not so well? I have an example. Vector of bools. Vector of booleans wanted to be a bit more efficient, storage efficient. So instead of holding the booleans as booleans in bytes, they decided to hold the booleans, each boolean, in a bit. But then when you want to get the value at index n, I can't return a bit by reference. So we return a proxy that represents the bit. And then any operation on the proxy eventually propagates to the bit, either reading or writing. And it works. But in a way, maybe you know that, maybe you will read about that. In a way, it doesn't behave exactly the same as any other vector. In which case, it means that, oh, I hide the implementation details of I'm using bits. You don't have to know that. But in a way, you have to know that. Because if you do not know that, maybe your loop would not work. You're looping with L-value reference. It doesn't compile. Oh, why? Oh, you should use R-value reference. Or, sorry, forwarding reference. Something is leaky in the way it is implemented. Hiding elbow functions. What about that one? Let's assume that we have a thingy and the thingy has two functions, foo and bar. You should not call bar if you didn't call foo. I mean, you can call only foo, that's fine, but if you want to call bar, you must call foo ahead. I think that I'm fine. I said that in the documentation. No, you're not fine. Somebody will call bar without calling foo. Do we have any other possibility? Yes, we can put both foo and bar in the private section maybe and then expose other API. Let's do that. Let's assume that we have foo and bar in the private section and then we have a foo bar. That's good if you always want to call foo and then bar. But if I only want to call foo in some cases, so maybe it's only foo, maybe it's foo and then bar. Okay, I have to do something a bit more complicated. Let's do the following. Let's assume that there is a function foo bar that gets a callback. I mean, that might be a solution. You may like it. You may come with another solution of your own. And then I call foo, and then I call your function, which returns a Boolean. It's a predicate. Should I call also bar? And if the predicate says yes, then I would call bar. Otherwise, I would not. It might be. Okay. Instead of function, you can just take a Boolean if you want. Another approach might be, let's assume that we have the foo function. And the foo function would call the inner foo, which actually does the foo thing. But then it will return a token that with which you can call bar. You cannot call bar without having the token that can call bar. And the token is provided by calling foo. So you call foo, and then even with chaining, as you can see in main, I can immediately call bar on the return value from foo. And the return value is an inner struct that has a pointer to the thingy that can call bar. So yeah, that's also a solution. I mean, we have to invest some work, but we are not lazy. We want to do that correctly. We don't want to allow you to call bar if you should not. Hiding helper functions, API should be hard to misuse. Using protected, what do you say about using protected? Should we use data members protected? I will give you an example that will, I think, convince you that we should not, I hope. Let's assume that we have a parent, the parent has a wallet, the wallet is in the protected, and the child has endless celebration function. I would say that protected would not work well here. I mean, that is not the exact metaphor which is correct, because in inheritance, the derived class is the base class. It's the same entity. And here, the child is not the parent. I mean, the child is, we can think in the real world, the child is another entity, is not the entity of the parent, in which case I can understand why the parent may want to leave the wallet in his pocket. But even in classes, even though the child is the same entity as the parent when you create the child, you still want to manage all the properties of the parent in the parent, because then your code is more maintainable, and you can then change the implementation of the parent. So I think that even though the metaphor is not exact, it is still convincing. So I would go with something much more secure, put the wallet in the private, and have a protected function. And the function would be need money. You can see that the API is bit changed. I want a reason. There wasn't a reason before because it was just a member. And you can follow the return type, which is a bit changed. Anyhow, endless operation can call now need money. But then need money may use throttling, may stop, may return 0. So my advice would be don't go with that, go with that, and strongly prefer data members to be private. Protected data members are wrong. Oh, you need to access them? Provide functions. Put the functions in the protected section. So prefer protected members over public if possible. If some function should not be exposed to the public, just put it in the protected if it should be used by the derived class. But the data members should be private. What about testing private behavior? I will not discuss that one because I don't have time, so I will skip it. I will just say that if you need to change your code in order to test private things, probably something is wrong. I mean, if you need to ask about a state, I would say, okay, give a getter. Let me have a getter, a public getter that can see the state. And you'd say, no, the state should be private. Yeah, but if the test needs that, you will find out that somebody else needs that as well. Tracing, log. Give me a getter. But if you need a setter, if you need to set something private in your test, something is wrong. You're testing some scenario that you cannot create for some reason, and it might be that this scenario doesn't really happen in real world. Or if it does happen, try to understand how you can create it. I have, I think here, I have a pointer to how you can actually go to private members, but Jody also discussed that in his talk, but we'll not go through that. Oh, I'm going back, sorry. Last item. I owe something. Do you remember what I owe you? I discussed something and didn't show how to solve it. Make unique. Constructor in the public, remember that? So we have a problem that is being solved with something called private token idiom, which has other names as well, with entry in Stack Overflow discussing what is the name which comes up with all these names and others. And the problem started with foo as a public constructor. The constructor shouldn't be public, but there are technical reasons why it is problematic, or I can even say we cannot put it in the private. So instead of putting that in the private, I would do something else. I would create a private token inside the private section. Then the constructor would expect a private token argument. Now, in order to call the constructor, you must provide a private token. And the private token can be created only either from the class or from somebody who is a friend of the class. And this actually solves the problem. Now make unique can work, and my factory can create, but nobody else can actually call the constructor. So yeah, you should do that, because otherwise we expose something. And now, yeah, we do expose the constructor in the public, but you cannot use it. Let's summarize. Hiding implementation details is more than just a design recommendation. It actually makes your code more robust and maintainable. It goes with encapsulation and decoupling. Two major things that we want. Having private fields is not enough. It is mandatory, but not sufficient. It is context specific. Something that might be public for one, maybe shouldn't be public for the other. So the solutions are interfaces, wrapper classes, maybe concepts. Keep abstractions. Being abstract is something profoundly different from being vague. The purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise, the extra. And it was shown at Ben Dean's another talk at CppCon 2023, I think, a very good talk. Go and watch that as well. Look for things that shouldn't be exposed and change them. Refactor. That's all. That is what I have to present. We have 40 seconds, I think, for 2 questions. Thank you. Come to the mic. There is a mic.
So I wanted to ask about internal structs inside classes, if they can be used to expose public members which are internal to the class.
So there was, I think, might be a slide on that and there are other slides that maybe I will do after the questions. There was a slide maybe on namespaces and private and public internal types like enums and structs. So in some cases, we would create structs or enums or classes in the private section. In some cases, we may want to create them in the public sections like iterators for list. So if iterators should be created and used not only from list, but by others, I would put it in the public section. So if this was the question, yeah, it depends on the actual usage.
Usually, I mean in a private section of a class for internal usages. So it's not passed through.
That's a solution. I mean, in some cases, I would create something in the private section. The proxy that maybe I provide outside, you know that in C++ I can provide something which is private for myself. The other side, the caller would get it. The caller cannot create that, but once it got this actual type, which is private in my type, it can use it. It can call any public function on this private type. So yeah, that's also a solution.
Thank you.
I think you took all the 2 questions. Thank you all. Thanks.